is let me explain in general how that table works, and then we'll get to the new kind of thing we're doing today. So first off, that's a table for giving you function values. So forget about all their hard questions right now. Let's just start with something like f of 2. What is that table saying is f of 2? Well, how you read that table, the top row is our inputs. It's our x's. You know, it's what we're plugging into the function. And then the f and the g, this is what comes out of f. This is what comes out of g. So if we put in 2, we put in a 2, what are we going to get out? So if we put in a 2 right there into f, what's going to come out? So you kind of like go down the f, down the 2, boom, out comes a 1. Does that make sense how I read that table? So basically you match up the row and the column to find what comes out. Remember, a function's like a toaster. You put stuff in, you get stuff out. You put in bread, get out toast. So let me show you one more time on that. So the top row is your inputs. So if you're putting in a 2, plugging 2 into the toaster, in goes 2. These are the inputs up here in the top row. Putting in 2, and you're saying what comes out of f? So you go down and row and column and match them up, out comes a 1. So let's try, what if I do like g of 3? So I'm putting in a 3.
Negative 3.
Yeah. Putting in a 3 right there to g. So go match up g and the input, out comes negative 3. So making sense what that table is saying? Get that? So the inputs, you find your input in the top, and then F or G, and you go across and down and where they meet. So I find my input up here in the top row, and I find my function, so 3 into G, then I go across and down, and where they meet, that's what comes out. Okay, so now now that we know the basics of reading that table, what is it they're wanting me to do today? Well, this first section we're looking at today, 5.1, is composition of functions. What just happened there? What that means is putting one function inside of another. So try to make it real first off. That'd be like putting your toaster in your refrigerator. Right? So remember, toaster's a function, right? Put in bread, get out toast. Refrigerator's a function. All by itself, it's a function. You put room temperature stuff in there, it cools it down. Thank you. I'm trying to go too fast today. Cools it down. Right. So you could put one of those inside the other. That's what we're doing with the F and the G today. That's what this is all about. So think with me. I know it's goofy, but it will show you the process for what's going to happen today in 5.1. If you put your toaster in your refrigerator, I don't know where the cord would go. We'll just let it come out. So you put that in there. Take a piece of bread, put it in the toaster that's in the refrigerator, push down the lever, close the refrigerator door. Wait a few minutes. What would happen? You'd hear the toaster pop inside the toast would pop up inside the refrigerator. Wait a couple more minutes while the refrigerator cools down the toast. Open it up. What would you find? Cold toast. So what happened? The bread was acted upon by the inside function first, huh? That's what's going to happen today. The inside function does whatever it's going to do that turned it into toast. And then when it popped out of the toaster, then the refrigerator started cooling it down. The outside function did his thing to it. And when it was done, both functions had acted upon it, right? That's what we're doing today. So when they give me f of g of negative 1, notice how I said that first off. That circle in the middle, that floating O thing, you read that of, what it means is g inside of f. That's what it means. This is just weird notation, this little floating circle thing. It means the G's inside the F. The toaster's in the refrigerator. That's what it means. G of negative 1 inside of F.
Oh, so
all these, yeah. All these little floating O things mean the right one is inside the left one. Okay. That's always what they mean. That's what that little circle means. It's called composition So it's like a musical composition, right? They take all the different instruments and they put them together to make a beautiful piece of music, right? They compose them. So that's what we're doing. We're putting these two functions together. So what they're asking me here on part A, when they say, what is f of g of -1, they're saying right to left. Functions always work right to left. That's not new, right? You've known that. Just a minute ago, I wrote stuff like f of 3, and you knew 3 went into f, huh? So functions always go right to left, don't they? So same thing here. So I'm going to say, okay, -1 into g, and then whatever comes out is going to go into f. It's always right to left. So let's start with that then. -1 into g. That's where we begin. We're going to pass through both functions. So let's find out, so what is g of -1? What happens when we put -1? So you find -1 up here. In the top row, you find your input. You find your function g. We're putting -1 into g. You go across and down. Out comes a 1, huh? So out comes a 1. So that means what? So the toast would pop out. Out comes a 1, which now goes into the refrigerator. Or the refrigerator starts acting upon it now. Right? Cooling it down. Right? Everybody see the action? So put -1 into g. Out popped a +1, a regular 1. And now put that. Now it's f of regular 1, isn't it? So find that. Here's 1. Find your input in the top row. F. Go across and down. Out comes -1. That's our answer to part A. So we went through both functions.
And we have to memorize the table for that?
What's that?
We have to memorize the table for that?
No. Yeah. This is the only table problem in the homework. No, they would give you the table. Yeah. So, yeah, we won't normally be doing tables. It's kind of a different one. Want to try B there? G of f of 0. Try that.
-3.
Yeah, -3.
-3 is going to be 3. Just 3. That's 3.
Oh,
So 0 goes into f.
-3.
So we would start with f of 0. So you put 0 into f. So we go. So find our input up here in the top row. Find f. Right. We're going 0 into f. Go across and down. -3. So out comes -3. So put the bread in. Toast popped out. So out comes -3 out of the f function. And now you put that in the second function. Put that in g. So now g of -3, right? What comes out of the first function then goes into the second. What comes out of the toaster is then acted upon by the refrigerator, right? So g of -3. So we go find -3 in the top row, our input. Find the g, because we're doing -3 into g. Go across and down, out comes 3. So that's our answer. Is that okay? See how that's working?
can I just do this for homework?
So far so good, huh? Okay. So I'm going to move on. Just make sure we're good with one at a time. How about like g of 4, for example? Do you remember how we had it on the last exam, huh? Function notation on graphs works. Basically, whatever's in there is x. What it equals is y. That's basically the key to reading graphs with functions. So when they say, what is g of 4? That's how you read that, g of 4, right? It's not times 4. It's g of 4. It's 4 in the g machine, in the g toaster. So g of 4, well, you go to the g graph, the top curvy graph, and you find the point that has an x value of 4 that's on the g graph. That would be this point right here, huh? And what's his coordinates? He's over 4, up 1. His x is 4. His y is 1. So that means the y is 1. Remember how to do that on graphs? How about if I gave you f of 3? So we go to the f graph, find on the f graph, the bottom, in the v graph, the f graph, find the point with an x value of 3, and find the y value that goes with it. So here's the point with an x. This is over 3 down 4. That's the point on the f graph with an x value of 3, right? X is 3. What's the y? -4. We good? So now I'll do the real deal. So that's just reminding you how you read values off a graph, function values off a graph. So now what they're really going to ask us for,
You're not gonna go by top?
top
Yeah, 3, 0.
3, 0. Oh, that one is the G graph. I asked you F on that second one. Yeah, that's all. Otherwise, you're great. Okay, so now G of F of -1. So in part A here, they want G of F of -1. So you know where to start, right? We start on the inside and go right to left, huh? So start with F of -1. Don't say it out loud. Give everybody a chance to find it on the graph. F of -1. Okay, so F of -1. So I go to the F graph, which is the bottom one, and I go to an X value. So to find F of -1, that's the X. Got to find the Y that goes with it. So that would be this point right here. So that's the point what? -1, up 0, that's the X, the Y. So out comes 0 from the first function. So out pops 0 and then goes into the G. So now I need G of 0. That's the X. I want to find the Y. Going with that. Is that so far so good?
I like this.
So go to the G graph now.
I like green patterns.
Go to the G graph and find the point up here on the G graph that has an X value 0. That'd be this point. Over 0, up 4. That's the X, that's the Y. So the final answer is 4. For part A. That good? Okay with reading those graphs? Composition of functions. So, you know, there's no secrets with me. Exam in 2 weeks, there'll be one of these two. I think from this point forward, there's no more graphs, no more graphs, no more tables. The rest is going to be just normal function stuff. But one of these two will be on the exam. I don't even know which one. I change it up semester by semester. But every semester, I either put one table one or one graph one, because I think they are good to help you to really think through what a composition of functions is really doing. So now, what are they going to want me? F of G of 4. So let's try that. So part A, they're going to say find F of G of 4. Okay, so now we're doing the same thing, but now we have X's. So you know the deal. It's right to left.
5 of 4.
Yeah, so take the 4 and put it into G, huh? Start right there. So find G of 4. So plug a 4 in. Right there like that, whatever that is. 32, 38?
I don't know. What's
38, yeah.
38? So 38 pops out of the toaster.
and it goes into this one.
And then the 38 goes into the F, right? What comes out of the first function, then goes into the second. So then F of 38. Now, am I going too quick? Are we good so far? So I put the 4 into G. Popped out with 38. This is what comes out. 4 went in. Out came the 38. Then the 38 goes into F. Now, so now I'm going to plug 38 into F. This is the F function, huh? So whenever you plug into the X spot, huh? So it'd be 9 times 38. Is that good? 270 and 73, 42?
342.
342, thank you. There we go. Is that good?
I like this. You should have 10 of these on the next test.
Questions? We all good with that? All right. All right, so part A again, F of G of 4. And try that one. So the 4 will go into G. So G of 4, cube root of 4. And you can't really do anything with that, huh? Cube root of 4 is just cube root of 4. They don't want a decimal number, and you can't. It's not 2, huh? It's not the square root. It's not the square root. So we just leave it like that. You know, they just want it left like that. But then, so that's what comes out. So now you got to put that into F, huh? Cube root of 4 into F. So we want F of the cube root of 4. And so what are we going to get then? So that's 14. It goes into the X slot. Whenever you plug into a function, it goes in the X slot. Cube root of 4 plus 5. Like that.
So we have to keep it like that, or should it go forward?
Yeah, good question. So we all good to there so far? That's actually the good final answer. I know you
Have a root in the denominator.
right, yeah, the whole thing about you can't have a root in the denominator, that's baloney. They just been making that up. I got to reveal the secret. Yeah, there's no problem really with roots in the bottom. There was in the olden days when they used slide rules. We're well past that now because it's along. So the root number is irrational, so the decimal never ends, so you can't find it on a slide rule, so you don't want it in the denominator, and blah, blah. We don't use slide rules anymore. We use calculators. So there really is no reason to not have roots in the bottom. You might wonder, well, then why do they make us do that all the time in algebra? And I do too. When I teach algebra classes, I make everybody get rid of the roots from the bottom because it's just good practice, you know. It's kind of like jogging, right? You would never pull over when you see a jogger and say, "Where are you going, buddy?" They go, "I'm just jogging, you know. I'm just trying to get in shape." Well, that's why they make you get rid of roots from. They're just trying to get you in algebraic shape. There's nowhere important you're really going with that. So, long story short, they'll let you leave them now. Now they're going to say, "All right, just leave them." So I tested it actually on the thing. It will accept that answer. So just like that. So some of those myths from your younger days are now being revealed to be false. Okay, so they're going to ask me for domain of f of g of x. Okay. So notice this time there's no number, right? Normally up to now it's been like f of g of 4 or I think it was that twice. Anyway, it's just an x now. So just x goes into g, which is that. That is g of x, isn't it? And so then that goes in f. So basically, I'm taking all of g, putting it in there and there, putting it in there and there. Does that make sense? It's really just putting all of g into f. So you're going to get, what are you going to get? You're going to get
Negative 8 over x over negative 8 over x minus 7.
yeah, like that. Is that good? To there? It's kind of a mess. We call that a complex fraction because it's fractions within fractions. You know, it's really messy. We never like to leave those things that way.
Are we going to put parentheses or anything or no?
You don't have to. They're not required here. Okay, so now what they are asking me to do though is domain. They're not. By the way, they're not asking me to clean this up yet. In about 2 problems, they will. So this one normally, in a couple problems, you'll be cleaning those up. We don't leave fractions over fractions, just because it's a mess. But this one, they're not making me do it, so I'm not going to do it. All they want is a domain. Yeah, all they want is domain on this one. So how do I look at that whole thing and find the domain? What if we've been doing a lot of domain in here? What is domain? What do we do when we do domain?
Values.
Yeah, acceptable, allowable exercise. Like I always do with the microwave, you shouldn't put tinfoil. Things that you shouldn't do, right? You shouldn't put tinfoil in the microwave. So what should you not do with functions? What's not allowed?
The denominator.
Denominators cannot be 0. And the other thing is square roots, if we ever have those, and we will in a minute, inside has to not be negative. How do you not be negative? What's not negative? Greater than or equal to 0, right? So those are the 2 trouble spots we look for. Denominators can't be 0, and the inside of roots can't be negative. Rebecca?
Any of the denominators. So the
Good.
denominator, okay.
So there's 3 denominators up there. Exactly. Rebecca's question is the germane one. What are the denominators? There are 3 denominators up there. This one, and the whole one. Those are all denominators, aren't they? Those are all under a bar. So anything under a bar cannot equal 0. Because denominators, because you can never divide by 0, that's infinity, right? So that means we have basically two different denominators. X cannot be 0, that one's easy enough, right? That's just that. Or that whole thing, which is minus x over 7 minus 7. I'm sorry, minus 8 over x minus 7 cannot be 0. That whole denominator cannot be 0. We got to solve that. Is that making sense?
Oh, 7, 8.
So every denominator cannot be 0.
Another fraction.
What's that?
Oh, never mind. Sorry.
That was good. So how do we solve for x here?
That's minus 7.
I'm going to jump that 7 over there, right?
Okay. Oh,
Like that?
it must be. Yeah.
I got I just added 7 to both sides.
I'm sorry. I didn't see it.
And now how do I solve for x there? Put that over 1 and go diagonal, diagonal. Remember, cross multiply is a pretty nice way to do that.
Wait.
So I'll bring it over here. So we get minus 8 times 1 not equal to 7 times x. That means minus 8 not equal to 7x.
Divide by 7.
And then divide by 7. You good there? Boom. So x not equal to minus 8 sevenths, and of course not equal to 0. There's our answer. There's the domain. X cannot be 0, and x cannot be minus 8 sevenths. Anything else is fine, but those are not allowed. They make various denominators 0. We good on that? All is well? Questions I can answer? All right. Okay. So try that one.
What is it asking us to do?
Oh, yeah,
Does it
sorry.
want fog? Does it want golf? Or
Just
does it
try.
want fog?
It wants f of g. It wants the fog. Yeah. And what it really wants is the domain of the fog. So it wants the domain of the fog, of the f of g of x. So so you know what to do, right? It's always right to left, so the g is gonna go into the f.
Which it already is.
So I'll take that whole g and put it right there into f. So what are we going to get? The square root of x minus 3 squared plus 6. We good so far? Is that making sense? I put the whole g into the f slot there. Now, I'm sure you're aware that we can cancel those, huh? But of this other fact, I don't think you are probably aware, and this is really important. Domain for domain, we must always find from the first step before any simplification. In other words,
Positive 3?
see, if I was to simplify this right now, you all know that those would cancel, huh? Right, roots and squares are opposites, and that would just be x minus 3, and then the plus 6, and it would be x plus 3. If I tried to work with that version to do the domain, I would never know that there had been a root there. And the root really was there, so it really is part of the domain issue. So that's a really important point. That'll come up 2 or 3 times in this section. We had it one other time in this course, but I know we've had a lot of things. I don't really suppose you remember that one particular problem, but we did have one other one where this issue came up as well. So at this point, it really will help you and serve you well to remember that domain, you always have to work with the first step before any cleanup is done, before any simplification, because you might cover up some of the hard spots. So, and domain is all about what would be hard for the function. So you have to always go from the first version. And in the first version, we have a root. And what have we learned? What did we say about roots with domain?
Negative.
The inside of any root greater than or equal to 0, not negative, in other words, right, which is greater than or equal to 0. So x minus 3 greater than or equal to 0, so that means x greater than or equal to 3. So that's the domain. X has to be only things 3 or bigger. So you can't put in like a 2, because that would make the inside of that square root negative. That's imaginary. Can't do it. But if you just looked at the end, the final cleanup, it would look like there's no problem with putting in 2. You know, but really there had been a root there that really was a problem. So yes, remember, for a domain, you must go from the first step before any cleanup. You got to see what was actually there before it was cleaned up for a domain. That's all they want. That good on that one? All they want is domain.
So, sorry.
No, it's good.
What we do is once, because we're not going to simplify that, so then we...
Right, so this really isn't even needed.
Okay.
I just did it for fun.
So we just switch it to, instead of an equals, it's greater than 30.
Right, because that's what not negative is.
Okay.
Yeah, not negative is bigger than 0, right? If you're not negative, you're positive. You're bigger than 0 or you're equal to 0. Yeah, because the inside of a root has to not be negative. Yeah, because that'd be imaginary. The root of negative numbers is imaginary. Now, in a minute, in a couple minutes, we're going to do a cube root. Is it okay to put negative numbers in a cube root? Like, can you do the cube root of negative 8?
Yeah.
Yeah, that's actually okay. That's just, what is the answer to that?
It's odd and negative.
Negative 2, huh? Because negative 2 times negative 2 times negative 2, 3 negatives, is fine. But you cannot do the square root of negative numbers like negative 4. It's imaginary, huh? So y'all good with that? So even roots you can't do. They're a domain problem. But odd roots could put anything in there. Like, so if this had been a cube root if this had been cube root of x minus 3, I would have said all reals, no problems. I wouldn't have taken that inside and worried about whether it was positive or not, because negatives are fine in an odd root, aren't they? Because you can have an odd amount of negatives to be negative. 3 negatives is negative. But 2 negatives, that's not negative. You can never have 2 things that come out negative, huh? Right? You good with that? So I want to make sure that's clear. It's going to come up in just a minute. So that's very different. Odd roots, anything goes. Even roots, we have our no way, not negative, got to do greater than or equal to 0. Okay, so we got F and we got G. And same kind of thing. This time they just want f of g and then the domain. Yeah. So first off in part A, they're going to just say what is f of g first off, and then down here they're going to say, okay, what is the domain of f of g? So first question, just what is f of g, and then what is the domain? Okay, so we got to take all of g and put it right there into f. So I'll let you do that. So we'll get 5x squared plus 7. That good for that? And then what's the domain? Yeah, all reals. Are we good? Because there's no roots, there's no denominators, so there's no problems, huh? If there's no square roots and there's no denominators, then there's no problems. It's just all reals.
So we can just type that phrase in? What we have?
Just type.
We do that.
Oh yeah, I think they'll have an option. Move forward on that. What is f of g? And then what is the domain? All right, so same kind of thing. Try that one. Put one function in the other. But remember, you want to do the domain before you do the cleanup, right? Remember that domain is always before cleanup. So grab G there and put it in right there. And so what are we going to get then? We're going to get 8 over 1 over x minus 9. Good to there so far? Now we have to clean that up this time. This time they will ask us to not leave it fractions within fractions. That's messy. That's complex fraction. Got to do some cleanup. But first, remember, do domain, right? So first do domain before we do any cleanup or any simplification, Okay, so let's do the domain right now. So domain, how do we do domain? Denominators can't be 0. Denominators can't be 0. So that'd be this little x cannot be 0 because he's under a bar. He's a denominator. And what else is a denominator?
1 over
That
x
whole
minus
thing.
9.
Yeah, 1 over x minus 9 can't be 0. Right, got two of those. So then that means move that 9 over. 1 over x can't be 9. Right, I just added 9 to both sides. Put this over 1, diagonal, diagonal. So 1 times 1 cannot equal x times 9. 1 cannot equal x times 9. Last step, divide by 9. X cannot equal 1/9. So x cannot be 0. X cannot be 1/9. There's the domain issue. Now, let's go back to cleaning up this function. So we handled the domain. X cannot be 0. X cannot be 1/9. But now, back to just cleaning up or simplifying the original f of g. We can't leave it that way. We can't leave it with functions within functions. So what do we do? Let me scribble all over this. No, let me make this a little nicer here. So how do we handle functions within functions? What am I going to do?
Multiply the top by the bottom.
We've had these kind of things before, haven't we? Think with me on this. We've had like 2/3 over 7/9. Right? We've had that. Remember what do we do with 2/3 over? Yeah, we grab the denominator and flip it up, and it comes upside down. And right, because divide. We've talked about how dividing is upside down multiplying. That's certainly true. We know how to handle it. But the problem here is we don't just have like one fraction on the bottom. We have two separate things, and not only that, they have a minus sign between them. Pluses or minuses in between things. Have you seen enough algebra now? Always make everything hard, don't they? Whenever you have plus, if this was times instead of minus, if it was times, I would just grab those two, and I would just grab that 1 over x, flip it up, x over 1, grab that, flip it up, 1 over 9, be a piece of cake. But it's not times, so you can't do that, right? If you've seen that, that's just all the way through. All the hard algebra rules. Pluses and minuses make everything hard, don't they? Because it's the whole Costco, glue together, stuck together, can't do anything nice thing, right? You with me? Because of that minus, these are glued together, so we can't do that individual flip it up, flip it up. So we can't do that. You can never do anything nice when pluses and minuses get involved. So then what do you do then?
I don't know.
Denominator. Yeah, exactly. This guy's the problem, isn't he? Think about who the problem is right there. It's him. Because he's the fraction within the fraction. So just get rid. What'll get rid of him? Multiply by x. But you can't just do one part. You have to do the top and bottom. That's what you do. Yeah, and that's certainly got to be legal, right? Because I'm doing the same thing top and bottom. So that can't change anything. So that's what you do. So 8x. These guys cancel. 1 minus 9x. There's our answer. Why is that better? Well, that's just a normal fraction. That's not fractions within fractions. It's not a complex fraction. That's what they want.
Okay. So the reason you have to multiply everything by x is the same reason you can only cancel if everything has x when there's a plus and minus involved.
Yeah, right. It's that plus and minus problem. Exactly. Hey, do you notice if I tried to do domain, if I had done this first and then tried to do domain from here, I would have only seen this denominator and said this denominator cannot equal 0, move the 9x over, divide by 9. I would have got the 1/9 answer, but I never would have got the 0 answer. Because the cleanup covered up part of the issue, part of the difficulty. So again, I'm still beating this drum. When you do domain, do it from step 1 before any cleanup, or you'll cover up part of the troubles and you'll get the wrong answer. Does that make sense? You can't do domain from the cleaned up version. You got to do it from the first step. All right. So this one's going to be difficult. F of g. So part A here. On part A, they want f of g of x, and then they're going to want the domain as well. So this is the hardest one. It's kind of ugly. It's good preparation for calculus, though, because there is this kind of stuff there. All right, so how do we do it?
Well,
You're
plugging
gonna
G
plug
for
in.
the
Yeah,
F.
that whole G in for F, right? Whole G. And right there. And right there.
Yeah, so you're gonna have x plus 3 over x plus 3.
Okay, yes, let's write out what we got. We've got, it's going to be minus 9 plus 8 x plus 3 over x minus 8 x plus 3 over x minus 8. Good there. So that's a mess, huh? Everybody see what we did? I plugged that whole x plus 3 over x minus 8 in for x and in for x.
Yeah, can't you put the whole number over 1 and then cross multiply to get rid of the fraction?
Well, first off, let's do domain. We don't want to do any cleanup before we do domain, right? So domain is first before any cleanup. So let's grab all denominators and say they can't be 0. So we have the x minus 8 itself. That one's easy enough. Cannot be 0. Move that over. X cannot be 8. And then we have the entire denominator. So the entire denominator cannot be 0 also. So that's x plus 3 over x minus 8 plus 8 cannot be 0.
Move the 8 over.
What did you say? Other than-
What's that?
Wait, what else did you say? Said the whole thing and what?
So the x minus 8 itself, that's a denominator, cannot be 0. And then the whole
Oh, okay.
denominator cannot be 0. So every denominator cannot be 0. So now we need to solve that. How do we solve that? Going to have to move the 8 over.
And then multiply top and bottom by. How big is that? Yeah. Is it x minus 8? It is.
And so now how do we solve that? What do you do there?
You can put 8 negative 8 over 1 and cross multiply.
Yeah, you're going to have to cross multiply. Put that over 1. Manuel and Blong, I'm sorry, I'm hearing your voices up here, which means other people being a little distracted. If you guys could be a little more quiet, please. Thank you. Just diagonal there like that. And then you move this over here where we have room. And 1x plus 8 not equal to minus 8 x minus 8. Bring that up there like that. And then we just distribute. Boom, boom. X plus 3 not equal to minus 8x plus 64. Now what do we do to solve for x there?
Get x's on one side.
Yeah, whenever you have x's on opposite sides like that, you just get rid of one of them. It doesn't really matter which one. So I'll just like add 8x to both sides. That's gone. So then I'll get, what's that, 9x plus 3 not equal to 64. Subtract 3. We're almost done with this one. 9x not equal to 61. Last step, divide by 9. There it is.
Yeah, 61 ninths.
61
I
ninths.
was thinking it was going to simplify up there.
What's that?
Oh, I thought I'd done something wrong because I thought that it was going to simplify nicely, but it's not.
Mm,
Yeah, no, unfortunately.
just
clean-
like that.
Yeah, clean numbers aren't like.
And we still got to do the cleanup on the top thing. That's just the domain. We're not done yet. Right, we have to take this guy and clean him up. That's right, they're going to want both things, and this is just part A. There's part B, part C, and part D. They do G of F, they do F of F, and G of G. These are a ton of work. I feel like I should apologize Yet, this is what it takes if you want to go to calculus. You got to learn all these algebra things, and it just takes time. All right, so we get there. Let's go do the cleanup. Any questions on the domain? Is that making sense? So now let's take this guy, go to a fresh screen, and clean him up. You can start, if you got it in a good spot already, you're going to multiply top and bottom by x minus 8, because that's the denominator causing problems. So just multiply here, 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 all four by x minus 8. That's what will clean him up. So let's go do it. So x plus 3 over x minus 8 minus 9. Okay, so there we go. So there it is again. Now we have to do the cleanup. We've done the domain, which we do domain first. We did that. I keep saying that because on the questions in the homework, they'll actually ask you for the cleanup before the domain. So it's almost like they're trying to trick you. So you got to remember when you do domain second, you really have to go back to what you had before you cleaned up, you know? So all right, so how do you remember how to clean up complex fractions? Well, just remember what the problem is. This guy's the problem and this guy, right? If they weren't there, this would be a normal fraction. Their presence is what's making it fractions over fractions, complex fraction. So you want to get rid of them. So that's what tells you to multiply by x minus 8. But you got to do everybody to keep the balance, right? So those are gone. It won't be a complex fraction anymore now. So what will it be? It'll be x plus 3.
Minus 9x plus 72.
And the minus 9 goes here. Minus 9x plus 72. Good job. Remember the double negative. Makes positive. And then on the bottom, x plus 3 again. And the 8 goes there. Plus 8x, whoops, minus 64.
Combine like terms.
Yeah, combine like terms. And we'll pretty much have it.
Negative 8
X and minus 9x is minus 8x
plus 75.
plus 75. X and 9x, I'm sorry, 8 and 8x is 9x. And 3 minus 64 is minus 61. There it is. That's part A of number 11. There's B, C, and D, which are just as much work. Yeah. Is that okay? Questions? You all right with that cleanup? All right. 12 and 13. Again, they're asking for f of g. So here's f of x.
Giving us variables.
Mx plus b. It's all letters. G is 1 over m x minus n. Okay. And so then they're asking for f of g of x, which means, g into f. So watch, something really nice is going to happen here. Let me move it over here. So we have room to do the nice thing.
Finally.
So, yeah. So G's going to go into F. Am I racing ahead of you? You good? So G's going to go into F. So I'm going to take all of G here and put it into F, right? Into the X slot, right? It's always X that we plug things into. Okay, so what are we going to get? M times G, which is 1 over m x minus n plus n. Yeah, right. Is everybody good to there so far? Everybody see what I did? They're asking for f of g, which means, functions right to left always. So I took g and I put it into f. So I put all of g right there into the x slot in f, huh? Okay, do you see what's going to happen? You ready for the cleanup? It's going to clean up amazingly. M and that's over 1, right? So those just cross cancel. So you just have x minus n and then plus n. What's that?
Minus n.
X.
Oh, yeah.
It's just x. That has a significance. Not only is that, hey, that's nice, that's clean, but also, let me just put it up here, that has a significant result. think about what that means. Think about the significance of that. We just took x, we put it into the g function, right? X into the g, then into f, right? Then it went into f, and when it came back out, it was the same way it started.
So you're doing the opposite.
So those are opposite functions. And they look like opposite functions, don't they? Look at this function. And he multiplies by m and adds in.
Right.
This multiplies by 1 over m and subtracts in.
That's just the reciprocal.
They're getting you ready for what we're going to do in about 5 minutes here. The next section, 5.2, which is all about inverse functions.
Oh.
Those are inverse functions. And this is the first way we start to see that something is an inverse function. If you take x and you run it through both functions and it comes back the way it started, that means that one of the functions is undoing what the other function did, huh? Does that make sense? If you start off x and you go through both functions, you come back the way you started, that means one of the functions undid the other one because everything's back the way it started, even though you went through both machines. So that means they're inverse functions. That's how you can test if two functions are really inverse functions. You can probably see it just by looking at these guys. But that proves, officially, they are inverse functions. They're undoing each other. We just proved it. And so what's going to happen? See, they did f of g. What's going to happen to you when you reverse it? Same thing. Don't even bother to waste your time. Answer's x. And so are they equal? Yes, absolutely.
Mind blown.
So, yeah, so that's going to be the case. 12 and 13 are going to do that on the homework. All right, I better move on. So, okay, so on number 14, they're going to say, hey, look at this function, h of x or whatever. They're going to say it's the square root of x squared plus 2. What they want you to do is they want you to start to see that as a square root function. That'll be like f, square root. And another function, which is x squared plus 2, and this has been put into there. That's what they want you to see. They want you to see that h is really a creation, a composition, a composing together of g into f, which is the answer to part C. So C is the answer to that one. The f is root, and the x squared is inside. They're saying, find f and g so that f composed with g does make h. That's what they're saying. They want you to see. They want you to start seeing it that way because that's helpful in calculus. In calculus, you'll take something like this. Calc 1, like not too far in, probably a month into Calc 1. You have functions like that, and you do something that's called the derivative. Anyway, but to do the derivative rules, it'll be very helpful and important to look at that as one function inside of another function. That'll help you know how to do the derivative rules. Something called the chain rule. You link up the functions like a chain. F and G end up linking up because they're the two that have made that other function. So, anyway, just something to see. So, 16 is going to give us S of R is 4 pi r squared. S of R is 4 pi r squared. And the other function, R of t is 2/3 t squared. Okay, and they're going to ask me for S of t, right? They're going to say,
4 pi r squared.
find S of t. Okay, so I remember when I was like y'all. I was a junior college student and taking math and science like you all are doing. And at this point in my taking of math classes, I didn't really pay much attention to the thing in the letters. It didn't seem important, and it really wasn't important up to now. That'll change a little bit at this point. So this is the first problem. They're really calling your attention to look a little more closely than we usually do at the letter in the parentheses. That'll start to matter a little bit. So let's talk about that a little bit. So S of R, what that means is S as a function of R. If you read all the words, they're blowing up a hot air balloon on this problem. And this is basically the surface area formula. I don't know if you know that one already. But the area around a ball, a sphere, is 4 pi r squared. That's how you find the area of a sphere. And so they're basically saying the surface area around the hot air balloon, how much balloon surface, is a function of radius. Meaning you give me radius, and I'll tell you 4 pi times that radius squared, that's how much surface area there is around that balloon. And then the second function here, this is radius as a function of time in seconds. So they're filling up the hot air balloon with air compressor. They're blowing air into the hot air balloon to fill it up. And basically it gets more and more full. The radius grows and grows and grows over time. So like after 1 second, the radius is just 2/3 times 1 squared. It's just 2/3 meters. And then after 2 seconds, more air's in there, and the radius is whatever that is, 8/3 meters, and on you go. So over time, the radius is expanding as the air compressor shoots the air in. And as the radius expands, of course, the surface area grows. Right? So what they want me to determine down here is they would like a direct relationship, no middleman. They want to go straight from time to surface area. They want to be able to know something that physics would do a lot, is they want to know at any time, tell me the total surface area. Right now, at any time, we can tell you radius and then use that to find surface area, but we want to cut out the middleman and go directly from time to surface area. How do you do that? Do you see it's just sticking one function in the other? It's just what this section is all about, composition of functions. In other words, if I can get rid of all my scribbles here. Basically, if I just take this right here and stick it right in there for R, I'll have it. Because this is R. This is the R function. And they want the S of t now. So notice I take 4, or let me keep the same color for making it make sense. 4 pi something squared. And what am I going to stick in there? 2/3 t squared. See how I just stuck R, right here in the S function. And now, see how this is now a function of time? It's only got time. So that's one of the real life ways that functions are composed with one another and why that's done. So then we just got to do a little algebra cleanup on that. So, right, because now I've got S. I used the S formula, didn't I? I used the S formula here, but I plugged in time. I plugged in radius, I'm sorry. I plugged in R, which gave me time as my only variable. All right, so let's clean that up. How do you clean that up? Well, that's 4 pi. How do you square all that stuff? You just square all that stuff. So you square the 2, it's 4. Square the 3, it's 9. Square the t, it's 4th power. Like that. Just square it, square it, square it. And then what do you do there? This is 4 pi over 1, so 4 times 4 on the top. 16, 1 times 9 on the bottom. 16 ninths pi t to the 4th. There it is. 16 ninths pi t to the 4th. So that's the surface area at any time. You could plug time into that and immediately know the surface area of that balloon.
Okay, sorry. The last step was...
So the last step, I squared everything.
Right.
And then I had to multiply these together. So this was a fraction. So I just did 4 times top, bottom times bottom, 16 ninths. Threw the pi in there, t to the 4th. I just multiplied fractions, basically. We good with that? Makes sense? Real life application. 17 and 18 are about the